At last. Fuel pressure's fine. Valves are all sealed. Nearly ready to go. Good job, too. I've about 12 hours left on my life support system. Another investigation. I hope it's a quick one.
Stella, we're having an argument here and we need your help.
My scales say the apples weigh 400 grams. They balance exactly.
Aha! They're old-fashioned balances. My scales are digital, and they say 400.767576.
It keeps changing, it can't be right.
Hold on. 400.77 grams. They're really accurate with decimal points.
Yeah, but mine say £1 exactly.
Old-fashioned units, that can't be right.
Stella, can you help? Who is right?
Even without seeing your scales, I can give you a quick answer. None of you are exactly right. There's no such thing as an exact measurement, whatever you're measuring. Some measurements are more accurate than others.
The story of measurement starts thousands of years ago, before any of these scientific instruments had been invented. To find out how heavy something was, you would compare it to something else.
It's easy to feel that this lead boot is a lot heavier than my deck shoe. But with more similar objects, like these goggles and this snorkel, it's much harder. I need a more accurate system.
One of the most important scientific inventions ever was this, a set of balances. They allow you to compare the weight of an object to some sort of standard.
These goggles have the same weight as one compass. But it's no good using a compass as a standard. You get about 6 pairs of goggles to this compass.
So you need an agreed measure, a universal standard. And for mass, it's the kilogram. For fair trade, it's vital everyone sticks to this standard.
I'm on a mission with Steve Playle, trading standings officer. We've had reports that a shopkeeper in here isn't measuring accurately. Right.
My job is to check the accuracy of measurements. In this van is our control room. I've got a secret camera. We are going to put our shopkeeper to the test and collect 3 pieces of evidence. And I have 3 different disguises. I'm about to enter the shop.
Roger.
Hello, please can I have 500 grams of biscuits? No, in fact, a whole kilogram.
I don't believe it. You should have weighed the box first. This way, you're paying for the box. Accuracy test fail number 1. When we re-weigh the same 1 kilogram of biscuits, we've only got 900 grams. This kind of mistake can also happen in the science lab. Containers are often used to weigh. You should always weigh the container first, then take it off the total weight.
Steve, can you read me?
Loud and clear.
Kilogram of biscuits, please.
Biscuits?
In a bag.
Biscuits. And that, I believe, is 1 kilogram.
This time he's reading the scale from the side.
198.
This time you've got more biscuits. Look at this. Whenever you take readings from a device with a needle, it's vital you take the reading straight on. Looking at the needle from the side can give you a higher or lower reading. It's called parallax error.
Right. 3rd time lucky.
Good luck.
Hello, handsome. I have a kilogram of your biscuits, please.
Biscuits.
I don't believe it. Those scales are already reading 250 grams and there's nothing on them yet.
1 kilogram.
You're going to be short of biscuits by 250 grams. You always have to reset the scale to 0 before you start weighing.
This is serious. It's illegal for shopkeepers to give short weight and inadequate quantity. Trading standards officers like Steve enforce the law.
Trading standards. We've got evidence on 3 counts of inaccurate weighing. You'd better come with us.
Fancy a biscuit then, Steve?
When you're weighing things, it's important to get scales that are suitable for the job. These feathers are so light, I don't even get a reading on these kitchen scales. But is there any point weighing this apple on these very accurate scales? Even the leaf would make a difference. Consider the measurement of a length in meters. This ruler is divided into meters, centimeters, and millimeters.
But with a microscope, each of these millimeters can be divided into 10. You can always be more precise. And sometimes high precision is crucial.
To the fastest people in the world, 1/100th of a second can make the difference between a medal or not. In sprints, a fast start can give you the edge you need to win.
On your marks.
My investigation
Set.
starts here.
At the Alexander Stadium in Birmingham. Hi, Susan. Hi.
Susan Boubier is an athletics timing specialist.
We can walk. Oh, good, thank you. Because that's where we have all the equipment that measures the reaction time.
Now reaction time is the time between when the gun goes off and the time the athlete actually leaves the blocks.
That's right. And it's such a small amount of time that you can't use a conventional stopwatch to measure it, and you can't often see it with the human eye either.
Hello, Richard.
Morning.
He's the guy that gets everything moving. So the sound of his gun activates a trigger which starts all the timing equipment in the stadium. And that time is measured to 1,000th of a second.
Thousandths of a second, well, that's 0.001 seconds.
That's right. And we can also measure the reaction time from here as well. This is the starting block. So the athletes press against these pads. When they hear the gun sound, they push back with a huge pressure, and that propels them forward. And this time is also measured to 1,000th of a second.
And both measurements have the same accuracy because it would be pointless having one measurement more accurate than another in any experiment.
That's right. And then all the data is fed into the computer.
So, how quickly can sprinters react?
Set.
This is the graph, so you can see the time along this axis and the pressure going up here. The straight line is where the athletes are in the blocks. The line coming down here is where the gun goes bang. And then you can see a sharp increase in pressure as the athlete reacts to the sound of the gun. The difference then is the reaction time.
All these top-class athletes react in just over 0.1 seconds. So how will my reaction time measure up?
On your marks. Set.
Could do better. About double the real athletes.
Set.
No better. But what if I guess when he's going to fire and react just before?
Set.
The system registers it immediately. A forced start. Look closely.
Set.
I move off the blocks just before he fires. I need help.
John Regis, just what I need, some expert help. What am I doing wrong here?
Well, first and foremost, starting is the integral part of 100-metre sprinting. And if you get this part wrong, you haven't got a good chance of winning the race.
What do you think about when you're about to start a race?
When the starter says set, all you're thinking of is reaction to the gun. Once the starter then fires the gun, it's just all about reaction. As quickly as you can, get into your stride and run as fast as you can.
Well, as you're here, John, you might as well make yourself useful and do some work on me.
OK, here we go. First and foremost, I think, I'm looking at your leg length, and it's obviously a lot shorter than mine, so I have to move this one a bit further forward to give you that ability to drive from the blocks. Second thing, get in a comfortable position. You look rather like a penguin, and penguins don't run very fast. What you've got to do is put your hands a firm base on the tips of your fingers.
OK.
All we're going to do now, I'm going to say set, put my hand there, and go!
Time to put it to the test.
Set.
OK, that was a good one.
But does the computer agree?
That was outstanding. Unbelievable performance.
I agree.
So, how did I do?
Femi, give up your day job and turn to track and field.
Really?
Absolutely. I mean, your reaction time was 0.180, which
Excellent.
is superb.
I'll see you in the Olympics a couple of years time. Watch your back, Mr. Regis.
I think I've got to go out now and do some training because I think you're after me, to be honest.
Do you think John Regis can guess how fast they run a race?
Yeah, but not to the nearest thousandth of a second.
Yeah, no way.
Well, how good are you at estimating time? How long do you reckon between these sonar beeps? No looking at your watches.
About a second?
Just over a second.
Exactly a second.
Well, it's 0.9 seconds, 9/10 of a second. Now, how long between the beeps?
You can hardly hear the gap. It must be 0.001 seconds.
Or 0.0001 seconds.
Actually, it's 1/10 of a second, 0.1 seconds. It's much harder to estimate very small times. And how long do you think you've been watching this program? No looking.
For ages.
10 minutes?
20 minutes?
You probably weren't even accurate to the nearest minute that time. While I prepare for launch, there's just time for one last investigation.
I brought along 4 experts. They all measure for a living, but today they're not allowed to use their instruments because we've set up an estimation challenge at Chessington World of Adventures.
First, meet John, a meteorologist.
I use a thermometer and I measure in units of Celsius.
Steve,
I use a tape measure, which measures in meters.
a surveyor. Pat, a nurse.
I use a watch which measures in seconds, minutes and hours.
And Russell, a chef.
I use scales which measure in kilograms and grams.
Maths first. Russell, you should be really good at this one. Back here we have Boris the sea lion. How much does he weigh in kilograms?
Well, I reckon Boris is about 5 times my weight, so I'm going to go for 400 kilograms.
No, I think that's way too much. I think nearer 250 kilograms.
I think, well, more than 3 times my weight, but somewhere in between, I think 325 kilograms.
I think Boris weighs 275 kilograms.
Now, we're not actually going to put Boris on the scales, but he did tell me earlier that he weighed 363 kilograms. So, Russell is the closest. Yay, Ross!
Thank you very much.
Time next. Now, Pat, you work with a watch. So what tips can you give us for estimating time?
When I estimate second, I say the word crocodile. For example, 1 crocodile is approximately 1 second long.
Crocodile. Works. How many seconds does it take a boat to travel down the chute. One crocodile, two crocodiles.
Okay, you intrepid sailors, you. What is your estimate?
Oh, I reckon 5 seconds. I reckon 3 seconds. 4 seconds.
I reckon 4 seconds. Well, Steve and Pat are absolutely right. 4 seconds. Any tips for estimating distance for the group?
Well, for shorter distances, I use my feet. I know they're approximately 1/4 metre long, so I can use that as a gauge of estimation.
And for longer distances?
I look at my own body again. I'm approximately 2 metres tall.
OK, team, how high is the reading on the high striker from here to the top of this purple bulb up here?
1.5 metres.
2.3 metres.
3.4 metres.
1.6 metres.
Let's measure this one. I'm making sure the bottom of the rule is bang up against the bottom of the high striker, making sure it's in the correct place and that it's straight. So, let's see. 1.6 metres. Spot on, Steve. This boy is good. And finally, temperature. So, John, how do you estimate?
Well, I like to use the clothes we wear as a gauge of temperature. So if we're wearing gloves, it's close to 0. If we have to wear shorts, it must be at least 20 degrees Celsius.
Last challenge then. What is the temperature of the water on Ramesses' Revenge? Well, I placed the thermometer in the water, just waiting for the mercury to settle, and looking at it head on, it's 23 degrees Celsius.
Given that water often feels hotter than it is on a cold day and colder than it is on a hot day, I'd say around about 23 degrees Celsius.
And I'd say 22 degrees Celsius.
No, I think it was colder than that. I'd say 18 degrees Celsius.
I reckon 23 degrees Celsius.
Well, the answer is in fact 23 degrees Celsius, so well done, John. But old Stevie Smarty Pants here, you got time, temperature, length, all right. You are the outright winner. Congratulations.
Thank you.
And for your prize, you have an entire afternoon on Ramesses' Revenge. Yes!
Let's estimate how long before Steve starts screaming. 1 crocodile, 2 crocodile, 3 crocodile.
Oxygen levels gone critical. Estimate I've got about 10 seconds.
10, 9, 8, 7,